Hello everyone, I wanted to give a brief introduction to our class talking about computer architecture and organization. This is both a computer science and an engineering track course, and I think you will enjoy the material that we're going to get a chance to cover. Let me just briefly go over some of the information that we have in our class based on the information from our textbook. And then I'll start to walk through three different projects that we'll be accomplishing as we go. The textbook does a nice linear way of walking through the elements that we want to make sure that people become proficient in it. So we start with basics, talking about the concept of digital logic. If you have had discrete structures as a class, you'll have some introduction to what is logic. Think in terms of and, or, and not. Those are three of the basic elements that you can start to assemble digital logic. So we'll go over that. Then we're going to talk about these three elements here: processors, memory, and I/O. And if you put these together, the most common way that I will be talking about in class is something called the von Neumann architecture, where these are the three things that what form the basis of a computer. And so we'll take them one at a time to get some more insight. We'll have three projects. The first one is going to be focusing mostly on digital logic, and we will start to introduce the idea of what an arithmetic logic unit is. It's basically a bunch of digital logic that's put together, and based of how you program the hardware of what it's supposed to do, it's like a Swiss Army knife, if you will, that it has a variety of functions, and you program it to do a specific thing, and once you've told that personality, it then acts upon data based on that set of criteria. The second project that we'll have is we'll be looking at assembly language, how you actually program processors. And assembly language is a way of getting access to that lower level information that you can't with higher level languages. And so we'll have a couple things that we'll look at there. And the third project that we'll do is getting at how you can actually program with hardware and software together with something called an Arduino kit. And so those are things that we'll cover. Let me just walk through some more details about some of these projects one at a time. The first is the digital logic design tool. And what I have here is I have loaded in one of the default scripts that is available from the website. And it's put into operational simulation mode. And so as a result, I can actually real time start to cause some real effect. And so the way that the arithmetic logic unit is set up, and I mentioned this, it has a programmable set of functions. And so here is a program of tell it what it's supposed to do with the data. And so there's two sets of data, and based on what is defined as its current function, it will respond in a certain way with two sets of 4 bits of information. You will be doing some circuits in this, and we'll talk about that in class. The second is looking at how you program in assembly language. We're going to be talking about the MIPS type of architecture and the type of assembly language that would be associated with processors in that area. Perhaps you've heard of x86, Intel, AMD. That's a different type of architecture. This is more geared for stuff that you would have in cell phones, tablets, and recently it's even starting to get into the desktop area as well with some of the major vendors moving in that direction. So you have basic commands, you have operands that those commands use, and then you can have comments. And so this gives you still a rational way in terms of how programmers are used to thinking. You can execute this, and what you can start to get insight is to how these commands actually start to deal down at a very low level hardware point of view with registers, and based of how we talked briefly, very briefly, about this arithmetic logic unit, you're programming it by line of code by line of code, and under that certain specific things are done. The specific program that is here is something called the Fibonacci sequence programmed with assembly language. More to come on that, but I just wanted to at least introduce that concept here. And the third thing that I'm going to show you is what we're doing with an Arduino kit. And an Arduino kit has a board that looks like this, and we can actually plug in our computer. And so I actually have something that has been ginned up, and I have a video, a separate video that you can get a chance to see this in more detail. But I'll just briefly show it to you just for completeness sake for this video. And so what you see down here is the actual Arduino kit, the Arduino board. It's plugged into my computer, and then I have some logic that I've actually put on here on this board here. This one specifically has a photoresistive diode that the amount of resistance that it produces varies with the amount of light that is actually on that sensor. If I was to put my hands over this, you can see how the LED on the circuit board changes, and also the display you can see actually changes. You can see how we're getting variation. If I was to shine a flashlight on this, you would also see how it would change more pronouncedly in a different way. And so those are the three things that I wanted to just briefly share with you in terms of the projects. So the textbook is Coomer. Doug Coomer is the person that has written our textbook, and this is the second edition, Essentials of Computer Architectures. And so that's a quick tour. And I figure a summary video might be useful for you guys as you're getting prepared for this class, and maybe you might want to review it as we work through the material. Have a wonderful day. Take care.